This is my lab 4 on oscillations. The purpose of this lab is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. Important models and principles for this lab: tracker software was used, GlowScript was used, and Google Sheets. For principles, Newton's second law of motion, stating that net force is equal to change in P over change in T. Then the energy principle. In this case, the change in energy is 0. And then the system is the mass, spring, and earth, and then nothing in the surroundings. And then some additional formulas that were also relevant: position update formula, velocity update formula, kinetic energy, gravitational potential energy, and spring potential energy. This is a preview of the result, showing what everything looks like in the end, and I'll explain how we got to this. Again, system, mass, spring, earth, surroundings, nothing. Some initial conditions: the mass was found to be 0.402. Then the initial position that came from analyzing the video and tracker was negative 0.039 and negative 0.633 in the y direction. Then solving for t, or the period / time needed for a complete cycle to occur, basically comes down to setting 3 times the full complete cycle equal to the mass, 0.402, and then that gives you a period of 1.23 seconds. And then solving for K, the spring stiffness, this was the formula I came up with for that, and plugging in all of the values, your mass, and then the period squared into that formula, the result that you get in this case is 10.49. And then finally the spring relaxed length L naught, plugging in all the values into this formula that I came up with, you get 0.324 meters. As far as coding, this is the most important part for getting the models that you'll see on the next page. But first, edited the mass, put in the 0.402 that was found, then put in the initial condition vector, the initial vector from the tracker software analysis. Then for the spring constant down in the second red box, put in that value that was calculated. Same with relaxed length, plugged in that value. And then in these next lines, I had to edit all of these formulas to get the right model setup and everything to work. So this is just, you can see in the second box, editing all of the formulas so that they correctly produce what we want. And then in the calculation loop, similar thing for the gravitational force, plugging in the correct formula there, negative, well in this case the variable is ball, but negative ball point m times g. And then editing the spring force, the net force formulas, and then applying the momentum principle here, updating the spring formulas, calculating energy changes formulas, all those good things in this last big red box. And so once you make all of those edits, then you get this result. And so what you'll see is that these graphs aren't exactly, the model and experiment don't exactly match. So the system is not isolated from surroundings in reality like the predicted model suggests. So we do have other variables in the actual experiment, such as a drag force, and that's a possible source of error and could be causing the discrepancy that you see. And then another possible source of error is the center of mass placement when going through the tracker software may not be completely accurate, which could also be leading to discrepancies in the data. Because when you're doing it so many times, it's easy to not necessarily place the point exactly in the center. And then to answer the big question, is the energy principle satisfied? Yes, since no external forces in the surroundings are acting on the system, the change in energy should be 0, which is correctly shown by the delta E orange line in this bottom picture. And then finally, if you were to compare oscillation periods in the x direction and the y direction, applying the same formula from the x direction, setting the 3t equal to the number of to the mass, and then solving. If you did that for the y direction as well, your answers are going to be different, which will also change the spring constant formula or spring constant value. And that concludes this lab.